All right, so now we're going to go ahead and graph our data with a frequency histogram, relative frequency polygon, and an ogive. So this just kind of gives you a brief overview of what the difference is between the four. And so we've got a table of data we've already been working with the previous problem. We have a frequency distribution, and here it is from the previous problem. So what we need to do is add a couple more values to our column to make sure we have everything we need to make all these graphs. One thing we need is our relative frequency. And to find relative frequency is pretty easy. You just take the number, your frequency, divided by your total. And so in this case, it's approximate 2 over 19 is approximately 0.105. 0.105. And so your cumulative frequency is also 0.105, which is also 2/19. Then you'd have 5/19, which is approximately 0.263. Then you'd sum up the top two, which is the same as 7/19, which is approximately 0.368. And then keep going down. This would be 9/19, which is approximately 0.474. And we're up to 16/19, which is 0.842. And then we've got back down to 2/19, which is 0.105. I forget to put the 0 in front. And then this would be 18/19, which we almost have it all, which is 0.947. And then we have 0 here, 0 over 19. And so the cumulative frequency stays the same, so 0.947. And then on 19, we've got 1 out of 19, which is approximately equal to 0.053. And that would be 19 out of 19, which is exactly equal to 1. And so we've got a cumulative relative frequency and a relative frequency. So now we're ready to graph these. So if you need to come back and see where I got my numbers, come back to this chart anytime. Just go back to 247 on the video. So here we go. Let's get started. So the first one's a frequency histogram. So some things you need a title. I've got this so it's kind of hard to see, so I'll slide it over. You also need to label your X and Y axis. So my Y axis is labeled frequency. And this is, if you remember from the video, it was graphing the height of plants. So frequency histogram for plant height. We'll give it a title. And we've got our X-axis labeled with the lower class limits. And notice I have a little break here. So we break it and we start at 1.5. Then we go 6.5, 11.5. So all of my lower class limits are listed. Other than 1.5, I want one past, just to go one past, I guess, on the 1.5. But I did label it also, this is plant height in inches on the x-axis, so we have something. And so if you go back to our frequency chart, from 1.5 to 6.5 there's nothing, but from 6.5 to 11.5 there are 2. And so you make a little chart, bar chart basically, that goes to 2. The difference is these are going to be connected. There's not going to be spaces between them. 11.5 to 16.5 there are 5. So you go up to 5, make your bar chart. And these, they don't overlap. I'm just sloppy. They would hit exactly. And then you would go 21 or 16.5 to 21.5. There are 9 of them. And I'll have to swoop up here. And there we have it. And again, I'm just sloppy. Those shouldn't overlap. And then from 21.5 to 26.5, there are two of those. And there we go, and it should stop right at 2. And then from 26 to 31.5, there aren't any. And then there's 1 in the final. And so here is your frequency histogram. Okay, it's very similar to a bar chart. The only difference is we have an actual X scale, and we connect it, we smush everything together. All right, so the next one is relative frequency for plant height. Relative frequency histogram. So again, it's another bar chart similar to what we just did. But now we're just going to plot those relative frequencies. So 6.5 to 1.05 has a relative frequency of 0.105. So it's just slightly higher than 0.1, 0.1. 11.5 to 16.5 is 0.263. So there's 0.2. 63 is going to be a little past halfway. So you do some guessing. Then 16.5 to 21.5 was a relative frequency of 0.474, so just under half. So 0.474, right in there somewhere. It doesn't have to be perfect, but if you're doing this electronically, it'd be better. 21 to 26 is 0.105 again. So we're back here to this, just a little bit above 0.1. 26 to 31, there's nothing. And then there's 0.053 is halfway way up. And so there's your relative frequency histogram. So you can kind of see the difference between those. And again, I'm going to extend this so you can see that I did label my x-axis, plant height in inches. And I got to hurry because I got to get this done in 15 minutes, so we'll hit the next one right away. So the next one is relative frequency polygon. And with this, the big difference here, you label everything, again, like normal, but take a look at my x-axis. We want the midpoint of each class. And so what I have there is the midpoint of each class. Now 4 obviously isn't the midpoint of any of my classes because that's 1.5 to 6.5, but I put it there. So 9 is the midpoint of 6.5 to 11.5. And so you just put a dot there where it begins. So 0.105 is the relative frequency for that class, so at 9. Then you put a dot at 0.263 for the next class. So there's 0.2, 0.263, just a little bit higher. And then 19 is 0.474. Again, just a little under 0.5. For the 24 class, that's back to only 2 of them, which is 0.105, so just right above that. And then for 29, there was nothing, it's 0. And then for 34, which is 32 to 36, there's 1, which is 0.5053. And the other thing is this has to be a polygon, so it has to be closed. So we started at 0 with 4, and now you just connect them, straight lines to vertices. Goes to 0 here, then back up, and then 39 would be 0 again to complete the polygon. And so there is, it's very similar to a histogram, but instead of putting bars, we put in points at the midpoints of each class. And so that's a relative frequency polygon. And you have to close it, where you start at 0 and you end at 0, so that it's a closed polygon. And finally, the last but not least is the cumulative relative frequency chart, which is called an ogive. So again, you can see I have labeled cumulative relative frequency to the left, and at the bottom we're back to our class sizes and our plant height in inches. I have all my class limits there. And so it's cumulative, so we're going to graph that. If you go back to the table and take a look at that, we're going to graph that starting at 6.5 was where the class began. And so at 6.5 we have accumulation of 0. Then at 11.5, the end of the class boundary, we've accumulated to 0.105. So you plot that point. At 16.5, we've accumulated 0.368. So here's 0.2, 0.3, whoops, 0.368 would be right there. We'll want to eliminate that point. And 21.5, we've jumped clear up to 0.842. So 21.5, 0.842, just a little bit under halfway. So right there. And so we've almost accumulated to 1. So we're ready for the next one, which is 26.5. And 26.5 we've accumulated to 0.947. So we'll put a point there at 0.947, which is about halfway. And then it's the same, nothing changed for the next one. And then finally, we have 100% on down. So if you connect these for the ogive, it connects here, then here. We have a real steep slope here, shallows off, no slope, and then it increases again. So there is an ogive curve from 6.5 on up to, so you start at 0%, you go to 100%. And so let's flash through these again just so you can see the difference between them all. So there's the ogive, cumulative relative frequency is an ogive curve. Then a frequency polygon has the big difference here is it has the midpoints of the class boundaries in it, graphed. Then you have relative frequency histogram, so it uses a kind of a bar chart system where they're all connected and you have an X scale. And again, your relative frequency is on the left. And you have a frequency histogram, which just has your frequency mapped on the left, and that should do it. And so those are your different charts: frequency histogram, relative frequency histogram, relative frequency polygon, cumulative relative frequency, which is an ogive. And again, I should show you everything's labeled, plant height in inches. I wasn't putting a title because I was getting kind of busy, but it's the ogive curve for plant height. So good luck. I hope this helps, and see you next time.